One of the most common devices to program, being a restaurant programmer, whether you're in the residential or the commercial side of things, is most likely a matrix device. One of the things I would notice about my program specifically is that the full encapsulating logic behind all of this stuff was becoming pretty repetitive, and that led me to believe that I was wasting a lot of time and doing things not as efficiently as I could be doing them. And so that took me on a venture to create a new Simple Sharp module that I think is pretty cool. So we're going to dive into the module itself, specifically the programming portion, and the symbols and their features. But before we get too far into that, I'm going to talk about a traditional strategy of programming just a single output on a matrix device in this case. And this may not look too unfamiliar, especially for people just starting off in restaurant programming. But what's going on here is you've got your core logic initializing an analog based on the physical indexing of where things are on this matrix device direct to the switch, and then in some cases people may not even be using the feedback of this. They might just be using the analog that they've set to the device for their UI feedback. But in the case that you do, you still need the virtual or the physical indexing based on the way this thing is wired up in order to get that feedback from the system. This causes some pretty big problems, especially when you're getting into programming larger systems. It becomes a juggling act. So in terms of the serials, the source properties, and indexing, this all needs to be maintained based on the physical I/O of the system itself. Comments, if you're using anything in terms of documentation for the indexing, you can't keep that consistent in some cases. Maybe you're good at it, but there's always potential miss updating comments, and then you've got comments that are out of date and not based on the actual indexing, and it can lead to confusion for yourself and other programmers, whether you're revisiting this code 3, 6 months, 12 months down the road. It's hard to maintain because there's little consistency. A scalable approach might look something like this. It may not look exactly like this for some people, but what's going on here is I'm using everything in my core logic based on a virtual indexing scheme, and then this gets remapped over to the physical parameters here that I need in order to set to my DM switch. And then same thing for the physical feedback. That gets remapped from the physical indexing layout over back to my virtual indexing, and then it gets fed back to the equate here. And if the analog is different, then it's going to set something else to go back through and set a new input on the switch. Otherwise it's not going to do anything. This was just a very simple example that I could come up with. It's not perfect, but it should portray the idea behind where this module is going. But looking back at this is still pretty complex. So how do we simplify this logic? And the solution that I came up with was a dynamic module using the power of Simple Sharp. Everything's fed from a configuration file. You've got a nice hierarchy of modules. Everything is based on a nice sequential virtual indexing scheme, and it's just easy to use. Advantages: you can avoid potential bugs, a lot of recompiling time, even potential future service calls going back to the same job. Everything is maintained based on the same core indexing. You've got input and output remapping as well as control endpoint remapping. All the serials are fed from a file as well, so you can manage everything literally from the file. There's even more advantages. You've got presets which are hard-coded in the file. They're configured by name, so you can recall this in your program based on the preset names. This means you can also set up presets that have really descriptive names that identify and make the presets in your program more intuitive and readable when you're trying to figure out what a certain portion of logic is doing. That's nice to have. Snapshots are like runtime presets where a user, based on how you've programmed the system, they can set up any runtime presets they want. and save and recall that from memory. Those are also importable and exportable to a file in case you need a cached version that you need to refer to or default back to in any case, or whether you even want to transfer this to another program on another controller. And then you've got the output control routing. So for instance, on a DM receiver where you've got DM endpoints off a DM switch, you can, if you change the output of where that receiver is on the actual switch, then obviously you can't control it at the same point from the program's perspective. So my module also will help you manage cross-point IDs based on the output remapping that can help you connect to the proper DM receiver off that frame, or even if you're doing something with NBX. In terms of my module, there's this concept of the virtual view and the physical view. So the physical view is something that the programmer wouldn't really have to deal with that much. This is just what the devices in your system will see. So this manages all that maybe unordered representation of the inputs and outputs for you, and it'll send that appropriately to the device based on what you're trying to do, based on a fixed virtual view of your matrix and your core logic. So you can see everything here is out of order. Things have been changed, obviously. So virtual input 1 is now physical input 3 in this case. But everything is sequential over here. Nice to deal with, nice to look at, and this is all kind of chaotic. So in terms of the module design infrastructure, you've got three layers essentially. The controller, each device, whether you have one or multiple, they're paired up with output control, routing modules, which is optional, and then of course your cross-point connections that this module will help you manage. So as mentioned, you've got the controller, the device, and the control routing module. The device module will control a physical matrix in your system. It can also be controlled by the controller globally. So this has stuff to recall presets across every matrix device in your system, or you can just recall it on the physical device, in which case that action becomes isolated to this physical matrix. This is also responsible for loading the configuration file, however, which is used by all the matrix device symbols in your program as well. And then the identifier, which you can see at the bottom, this needs to match what is in your config file for your matrix definition, but this makes it really easy to do a correlation between which device in your program maps to what configuration in your file. So next up, we'll move on to the configuration. The way this works, I call this the smart initialization mechanism, and there's 3 steps mainly. This last step will loop back to here, but the configuration gets loaded. Currently only JSON is supported, so this must be a JSON file because the parser type is chosen based on the file extension. I'll talk more about that in the next slide. After the definitions get loaded, each device module receives their matrix definitions, creates their own virtual switch in memory after being parsed from the file, which is sent to the device from the control module. Once the definition is fully loaded from the matrix device, the controller is notified that that device is fully initialized. And once all modules have been reported back to the controller as fully initialized, the controller allows all the modules to process the signals. So it sends out one more final notification to tell the devices that everything's been initialized in the entire program. And the way that works is, depending on the number of matrix definitions you have in your configuration file, every notification that the controller receives for a device initialization message will be compared against that count. And as soon as the initialization count for the devices matches the number of definitions in the file, then the controller knows that everything's been initialized in the system. So that means you don't have any ties in SIMPL to tie things in terms of initialized outputs back to the controller input or anything weird like that. It's all managed for you in memory. So here's a very basic JSON config example. XML is on the roadmap for support, since it's probably the second most common standard configuration file type format. The reason why I went with JSON first is because it's a little more minimal. It's easier to deal with, in my opinion, and the overall file size is going to be much smaller because you don't have all these XML tags and stuff that looks pretty ugly to me. In this case, you've got two matrix definitions. So this is an array, a JSON array. Matrix identifier 1 and matrix identifier 2. This was used for my testing. But you've got inputs, outputs, snapshots, catch file. This is where the import and export thing is concerned. And routing presets, which is based on the virtual input and virtual output mapping. And then your preset names. Both inputs and outputs have names, virtual to physical mapping, but the outputs also have the cross-point IDs for the control output remapping. So this makes it really easy to manage everything in your system just from a file. You don't have to change any of your code most of the time, and it's very easy to read as well. So we'll end this with the return statement, in other words, the end of the presentation. And I had thought to include this quote by Donald E. Knuth. I think it relates heavily to the motivation behind this module and why I developed it. But he says, the best programs are written so that computing machines can perform them quickly, and so that human beings can understand them clearly. A programmer is ideally an essayist who works with traditional aesthetic and literary forms, as well as mathematical concepts to communicate the way that an algorithm works and to convince a reader that the results will be correct. So in other words, you're providing more of a guarantee to yourself that the results will be expected by making the program easier for yourself and other programmers to read, and by simplifying it as well. And that is all. Before we close this recording, I just wanted to demonstrate the organization that these modules can provide for your logical subsystem structure here. So you've got the controller. Each matrix device has its own subsystem. You can manage all the logic in here, and then the control output remapping logic for the output device control, you can manage all that in here, and that's controlled by your cross-point folders. So it's a very logical and consistent folder structure, and none of this will have to change because you're going to be using all your virtual indexing rather than the physical indexing that is subject to change, and then you don't have to change things across your entire program.